The dance of distant worlds. In the farthest reaches of our solar system, where the sun's light is a mere whisper and the void stretches endless and cold, a small, enigmatic world named Pluto carved a path through the cosmos. For nearly a century, since its discovery in 1930 by a young astronomer peering through a telescope at the Lowell Observatory, Pluto has captivated humanity's imagination. Once hailed as the ninth planet, it was later demoted to a dwarf planet, a decision that sparked heated debates among scientists and space enthusiasts alike. But its reclassification did little to dim its allure. Pluto, with its eccentric orbit and mysterious nature, has always been a puzzle, a celestial riddle that challenges our understanding of a universe. Now, in the spring of 2025, whispers of a cosmic catastrophe have begun to ripple through the astronomical community. Pluto, the diminutive wanderer, is on a trajectory that could one day bring it perilously close to Neptune, the azure giant of the outer solar system. The possibility, though remote, has ignited a firestorm of speculation. Renowned scientists like Neil deGrasse Tyson and Michio Kaku have sounded the alarm, warning that a collision between these two worlds could send shockwaves to the delicate balance of our solar system. But how did Pluto, so small and so distant, end up on a collision course with a planet as mighty as Neptune? And what might such a galactic clash mean for Earth? A cosmic outcast. Pluto's story begins in the icy fringes of the Kuiper Belt, a realm of frozen comets and dwarf planets far beyond the orbits of the gas giants. Discovered by Clyde Tombaugh, Pluto was initially celebrated as a planet, a distant cousin of Earth, Mars, and Jupiter. But as astronomers studied its path, they realized Pluto was unlike its planetary siblings. Its orbit was not a neat, circular loop like those of the major planets, which glide along the ecliptic plane, the flat disk where most of the solar system's worlds revolve. Instead, Pluto's orbit is a wild, elliptical arc tilted at a steep 17-degree angle, like a rogue comet blazing its own trail. This orbit takes Pluto on a 248-year journey around the Sun, a marathon so long that it has yet to complete a single lap since its discovery. At its closest, Pluto dips within 30 astronomical units, AU, of the Sun, closer than Neptune, which orbits at roughly 30 Australian dollars. At its farthest, it retreats to a staggering 49 Australian dollars, nearly twice Neptune's distance. This elongated, slanted path means Pluto's journey is a cosmic roller coaster, weaving in and out of Neptune's orbit every 20 years in a dance that defies expectation. For decades, astronomers have marveled at this peculiar orbit. It's as if Pluto is thumbing its nose at the rules of the solar system. Neil deGrasse Tyson remarked in a recent lecture, his voice tinged with both admiration and concern. Its path is chaotic, unpredictable, and yet somehow stable. It's a reminder that the universe is full of surprises. Tyson, with his knack for making the cosmos accessible, has long been fascinated by Pluto's defiance of convention. But his tone grows serious when he speaks of its potential to disrupt the solar system's harmony, the gravitational waltz. To understand why Pluto's orbit is so extraordinary, we must first explore the intricate mechanics of the solar system, a celestial ballet where gravity is the choreographer. Every planet, moon, and asteroid exerts a gravitational pull on its neighbors, tugging and shaping their paths over eons. Pluto, though small, is no exception. Its orbit intersects Neptune's, a fact that initially baffled astronomers. How could two worlds, one a gas giant 17 times the mass of Earth and the other a tiny dwarf planet, share such a dangerous proximity without catastrophe? The answer lies in a phenomenon known as orbital resonance, a delicate balance that keeps Pluto and Neptune from colliding. Pluto orbits the Sun exactly twice for every 3 orbits of Neptune, a 3:2 resonance that ensures the two never meet at their orbital crossing points. When Pluto crosses Neptune's path, it is always at least 90 degrees ahead or behind, a cosmic safeguard known as azimuth libration. This gravitational choreography, combined with latitude libration, which keeps Pluto above or below Neptune's orbital plane, prevents a direct collision. It's like a perfectly timed dance. Michio Kaku explained in a recent interview, his eyes alight with the wonder of the cosmos. Kaku, a theoretical physicist known for his work in string theory, sees Pluto's orbit as a microcosm of the universe's fundamental forces. Gravity is the glue that holds this dance together. Without it, Pluto and Neptune would crash long ago. Kaku's fascination with Pluto extends beyond its orbit to its potential to unlock secrets about the nature of gravity and space-time, secrets that could reshape our understanding of the universe. Yet, despite this intricate balance, the possibility of collision cannot be entirely dismissed. Pluto's orbit is not a perfect ellipse, but a chaotic, ever-shifting path influenced by the gravitational tugs of Neptune, Uranus, and even distant Jupiter. In the late 1980s, computer simulations revealed that Pluto's trajectory is highly sensitive to its starting conditions, a hallmark of orbital chaos. A tiny nudge in its position or velocity could, over millions of years, send Pluto careening toward Neptune or spiraling out of the solar system entirely. The warning bells. In early 2025, a series of new observations sparked renewed concern. Advanced telescopes, equipped with cutting-edge imaging technology, revealed subtle shifts in Pluto's orbit, changes so small they would have gone unnoticed a decade ago. These shifts, while minor, suggested that Pluto's path might be less stable than previously thought. Could the dwarf planet's erratic orbit eventually lead to a catastrophic encounter with Neptune? The question hung heavy in the air as astronomers gathered at conferences and observatories to debate the implications. Neil deGrasse Tyson, ever the voice of reason, took to the airwaves to address the growing speculation. The chances of collision are slim, he said, his trademark charisma tempered by caution. But slim is not zero. If Pluto and Neptune were to collide, the energy release would be unimaginable, equivalent to billions of nuclear explosions. The debris could destabilize the orbits of other bodies in the outer solar system, potentially sending fragments toward the inner planets, including Earth. The idea of a cosmic collision, however improbable, captured the public's imagination. Social media buzzed with theories, some grounded in science, others veering into the realm of science fiction. On X, posts ranged from sober discussions of orbital mechanics to wild speculation about alien intervention. One user quipped, "Pluto's out here playing cosmic chicken with Neptune, and we're all just watching from the sidelines." Another posted a meme of Pluto as a rogue skateboarder, weaving through the solar system with reckless abandon. Michio Kaku, meanwhile, offered a more philosophical perspective. Pluto's orbit is a reminder of how little we control in the grand scheme of the universe, he said in a podcast episode that went viral. It's chaotic, yes, but there's an underlying order, a balance of forces that has kept the solar system stable for billions of years. Studying Pluto helps us understand that balance, and it could guide us in navigating the cosmos as we venture beyond Earth. The cosmic puzzle. To unravel the mystery of Pluto's orbit, astronomers rely on a combination of observation, mathematics, and computer simulations. Terms like VSOP oscillation, named after the astronomers who developed models to predict planetary motion, describe the complex interplay of gravitational forces that govern Pluto's path. These models, refined over decades, reveal that Pluto's orbit is not only stable but remarkably resilient. Despite its apparent chaos, it has remained intact for billions of years, a testament to the solar system's intricate design. Yet, the unpredictability of Pluto's path poses a challenge. Even the most advanced simulations struggle to predict its long-term behavior with certainty. It's like trying to forecast the weather a million years from now, said Dr. Elena Martinez, a planetary scientist at the Jet Propulsion Laboratory. We can model Pluto's orbit for centuries, maybe millennia, but beyond that, the variables become overwhelming. A single miscalculation could throw everything off. This uncertainty has driven scientists to monitor Pluto with unprecedented precision. Telescopes like the James Webb Space Telescope and ground-based observatories in Chile and Hawaii track its every move, feeding data into supercomputers that simulate billions of years of orbital evolution. These simulations have uncovered a startling truth. While Pluto's orbit is stable for now, it is not immune to change. Over millions of years, the cumulative effects of gravitational tugs could push Pluto closer to Neptune or fling it into the void of interstellar space. The stakes of a collision. What would happen if Pluto and Neptune were to collide? The scenario, while unlikely, is a sobering thought experiment. Pluto, with a diameter of just 2,377 kilometers, is a mere speck compared to Neptune's 49,244-kilometer girth. A direct collision would see Pluto obliterated, its icy crust and rocky core shattered into countless fragments. Neptune, though far larger, would not emerge unscathed. The impact could disrupt its atmosphere, alter its orbit, and send shock waves through its system of moons. The debris from such a collision would pose a broader threat. Fragments of Pluto could scatter across the solar system, potentially crossing the paths of Uranus, Saturn, or even the inner planets. While Earth is unlikely to face a direct impact, the disruption of the outer solar system could have cascading effects, altering the delicate gravitational balance that keeps our cosmic neighborhood stable. For Tyson, the possibility underscores the importance of continued exploration. Pluto's orbit is a wake-up call, he said. It reminds us that the universe is not a static place. It's dynamic, ever-changing, and we need to keep our eyes on the skies to understand what's coming. Kaku, meanwhile, sees the study of Pluto as a stepping stone to broader discoveries. The forces at play in Pluto's orbit, gravity, resonance, chaos, are the same forces that govern the universe, he said. By studying them, we're not just learning about a dwarf planet. We're learning about the fundamental laws that shape reality itself. A window to the cosmos. As astronomers continue to probe the mysteries of Pluto's orbit, they are also looking beyond our solar system for answers. Systems like TRAPPIST-1, with its 7 Earth-sized planets locked in tight orbital resonances, offer clues about how gravitational forces shape planetary motion. Rogue planets, drifting through the galaxy without a star, provide another piece of the puzzle, showing how celestial bodies can survive in the chaos of interstellar space. Pluto, in its own way, is a bridge between these worlds, a reminder that even the smallest objects can have outsized impacts. Its orbit, with its wild swings and delicate balance, is a microcosm of the universe's complexity. It challenges us to think beyond the familiar, to embrace the unknown, and to marvel at the forces that keep the cosmos in motion. For now, Pluto continues its lonely journey, a tiny world dancing on the edge of the solar system. Its path may be erratic, its future uncertain, but one thing is clear. Pluto's story is far from over. As we watch from Earth, peering through telescopes and crunching numbers in supercomputers, we are drawn ever deeper into the cosmic dance, a dance that began billions of years ago and will continue long after we are gone. In the words of Neil deGrasse Tyson, Pluto is a reminder that the universe doesn't care about our definitions or our expectations. It just keeps moving, and it's up to us to keep up. The watchers of the void in a quiet observatory perched atop Mauna Kea, with thin air and star-studded skies, offer a window to universe. Dr. Aisha Rahman hunched over a computer screen, her eyes tracing the latest data on Pluto's orbit. As one of the world's leading experts in celestial mechanics, Aisha had spent years studying the dwarf planet's erratic path. Her simulations, powered by algorithms that could model billions of years in mere hours, were among the most advanced in the field. Yet, even she felt a shiver of unease as the numbers flickered across her screen in the spring of 2025. The data confirmed what astronomers had begun to suspect. Pluto's orbit was shifting, ever so slightly, in ways that could bring it closer to Neptune than ever before. The 3:2 resonance that had kept the two worlds apart for billions of years was still intact, but subtle perturbations, perhaps from the distant influence of a rogue comet or the cumulative tug of Jupiter's massive gravity, were nudging Pluto's path into uncharted territory. Aisha's model suggested that, in a few million years, the dwarf planet's orbit could become unstable, increasing the risk of a catastrophic encounter with Neptune. She leaned back in her chair, rubbing her temples. "This isn't just about Pluto," she murmured to herself. "It's about the whole solar system. If we don't understand this now, we're flying blind into the future." Aisha wasn't alone in her concerns. Across the globe, astronomers were buzzing with theories and debates, their voices echoing through conference halls and X-posts. Some dismissed the collision risk as negligible, pointing to the vast distances and precise gravitational mechanics that kept Pluto and Neptune apart. Others, like Aisha, saw the data as a warning, a reminder that the universe, for all its apparent order, was a place of unpredictable chaos.